Greetings, AISC. My name is Ryan Curtis. I am a senior structural engineer and project manager, PE, at Leo A. Daly in Omaha, Nebraska. I'm excited to talk to you today about this VA ambulatory care center located in Omaha, Nebraska, serving our veterans in Nebraska and Iowa. The project consisted of healthcare, 9 different clinic pods, some with women's health dedication, surgery, radiology, lab, pharmacy, the whole gamut. So it's been a very promising and important project for our veterans in the community. Leo Daly was structural engineer and McCarthy was the contractor on the project. I'll be pulling some data from the previous Modern Steel Construction publication in August of 2020. In that actual publication, I talk about the P3 process, public-private partnership. This was the first of its kind in project delivery, where we took a nonprofit entity with a government entity and created a construction project out of that with the funding mechanism. So we had to make sure that that project was on time and on budget, a lot of focus on this project. And so we're, again, excited to have this article published and also to be able to talk to you today about the project. So real quick on the site, this is located in Omaha, Nebraska, as I mentioned. 42nd and Center is kind of the eastern part of the city. Tremendous grade drop of the site from the east to west. The building is rectangular in plan, so the long direction, the building drops about 20, 30 feet. So we had to do some tremendous surcharging, filling, and even a big cut into the earth. And so you can see here, the photo on the right is a soil nail wall, and that was where we were cutting into that earth wall to maintain the main entrance into the hospital. If we didn't use that, the main entrance would be closed, and that would be not satisfactory to the VA for access for our veterans and those from the city to make ability to get to the project site. We also had the auger cast in place pile contractor, was the same group that did the nail wall, which was great for the contractor in time for scheduling purposes. The project Superstructure was, like, as you can imagine, structural steel. And you can see here in the photo, the project, this is the north elevation, which I'm going to be talking about later, the north flag wall. This part of the building was one of the most trickiest and dynamic pieces I've been a designer for in years and years at Leo Daly. You can see there's a lot going on at the ground with the grade beam and the stem wall that's moving in and out of the plane from the building facade. Also, the floor levels have the juts out and to and from the main building line across that facade, and we will get into more of that later, but this is just kind of a good snapshot of what that looks like before the envelope goes up. The floor construction was conventionally slab on concrete deck, about 1,400 tons of steel. Moment frames, bays were commonly in that 28 to 35 feet geometry. Moment frames were used. It's a flexible building, but we use the moment frames to provide access and flexibility to the client. Most of our healthcare facilities, just after a couple of years, they have renovations, and so we want to make sure that we have anything that was going to be disallowing them to make those renovations and make sure they have an open floor plan for the project in the healthcare facility for years to come. With regards to connections on this project, we utilized AISC's design option 3, this code of standard practice for delegated design. And so we worked hand in glove with the fabricator, which was PVS. And so the folks at PVS, specifically Mark Holland and others who are part of the AISC committees, provided connections to help our project. The construction for steel, most of it was occurring in the first winter month of the project construction. And with the winter months being as brutal as they are in Omaha, we needed to minimize as much field welding as possible, so we had lots of bolted connections. Almost all of the moment frames are bolted connections. So you see here a combination of end plate and top and bottom plate connections. They estimate that this saved up to 1,500 labor hours saved on the project, which was important for the VA and important for those funders for the project. Also unique to the project was the vibration aspects of this project. So any healthcare facility has vibration issues to make sure you're looking at, whether it's for a radiology, MRI, or an OR. So this facility, as I said, had operating rooms, and so those operating rooms do optical surgeries, glaucoma, and others such as that. So we had a 4,000 micro inch per second criteria in the design of the floor slab system. We had to thicken the slab, also deepen, stiffen the floor beam members, and also tighten the spacing. And that got us to where we needed to be for the floor vibration. Also, on this project, we had stairs. One monumental stair in the main entry, kind of a two big grand story entrance to the project. Using AISC design guide, we learned that with our analysis, the folks walking up and down the stairs weren't experiencing that vibration, but if you were at the landing that you can see here in the middle of the screen, there was going to be some movement perceived. And so in a healthcare facilities, folks who are there for care, we want to make sure we're tight with that. So we don't want to have too much vibration. So you can see in the image, there is a steel tube column post underneath that landing. And so delivering the news of that to the architecture was tough one for them to understand and swallow. But what we ended up with, which was a great solution to the project, was this. Joined the marriage of architecture and structural together, created a backspan condition for that stair, and also was able to use that backspan condition where that post was sitting and now buried in that wall, create kind of a bench and a seat, and also meeting ADA compliances for walking under stairs in that regard. So this was a very great solution of the stair structure and the aesthetics coming together. Another great aspect of the project was the envelope. The skin on this building is one of the most significant parts of the project. And so we have curtain wall, metal panel, precast, brick, stone, screen wall systems, hiding mechanical systems on the roof. And you're seeing some images here that are showing what's happening there with the building facade. The structural engineering on this project had to be hardened for those envelope areas. Again, this is a VA facility, so we had to meet the physical security and resiliency design guide. And so things that were designed here on the structural side, the symbolism of the project went from architecture and had to be supported by the structural engineering. Talk about the American flag, talk about the soil, the granular aspect, the roots, the Midwestern culture, and for this Veterans Affairs building being Nebraska and Iowa, the farming aspect and the duty and what that means to most of our veterans, and also the ribbon, the veteran honors, the colors you see on the right, that image. Those all got worked into the project envelope, and you'll see that here moving forward here. The first image is the north curtain wall. Again, this is a hardened facade, and if you recall, we had the structural floor system moving in and out of the building. This is the American flag essentially frozen in time. The peaks and valleys and folds, creasing of the flag. So every person walking through the atrium of this facility experiences and is enveloped in the freedom that comes from the vet's sacrifice. So this flag wall at every floor level moves towards and away. So it's tilting towards and away from the ground, and it's also at different locations along the plan geometry. So we had to use a intricate study of our Revit models with our curtain wall manufacturer for the fabrication components to make sure that all these nodes and connection points, again, these are big loads, were tied in and accurately located for the structure to receive this curtain wall system. Next component, again, is this, you see some colors on the floor there. That's from the ribbon wall. We'll show you in the next slide. But the stone system, which we supported off structural steel in the in wall, is a limestone wall that basically cuts through the building from the slab on grade at the bottom level to the roof. And that's a reminder to the veterans that they are now at home with their soils here in the United States, and that they are safe. And it's representative of the layers of conflict, wars, and missions and soldiers that our soldiers have fulfilled over the course of many, many, many generations. The ribbon wall, this is now the west facade, is again a representative symbolism of the ribbon racks on the uniforms that our servicemen and women wear. This is a hardened envelope with the steel back structure to it. The steel on the inside of the building is exposed, painted, and on display. On the outside, you get this aesthetic look of the color shining through that envelope. It's just a beautiful thing to experience, is to walk through that facility and experience that. This is the good image that shows the front lobby of the veteran facility. As you can see, the structure is tilting this away from plane, so we have some geometrical challenges there. The existing hospital is off to the background on the right. The soil retaining wall is back on the right there as well. So you can see kind of how the grade would have been rising to the right in the screen. On the very left there is also the AESS canopy structure, which I'll be talking about next. So we did have 2 levels of AESS in this project, levels 1 and 3. And so we followed the specifications 05, 12, 13, and wanted to make sure that the steel that we used all over this project, where we wanted to expose it, was presented and demonstrated in a great manner. And so our documents, working with the fabricator, contractor, doing job site visits, doing the fabrication visits to the plant to look at the mock-ups, all of that was documented and followed through quickly to make sure construction was meeting the level that we wanted to meet for the process of AESS, exposed structural steel, and also the finished product. And so here's a couple images of that front canopy structure before final mid coat and the final top coat. The first coat was a zinc-rich primer. Second one was an epoxy, and then we had a tennemic final painting on the top for the color and for the gloss we desired, and also to protect the structure from long-term exposure to sun. Here's another look at that front. You can see again a pretty interesting dynamic of the canopy structure and the flag wall behind, and then finally after the final coats, this was the look, and you can see the mat and the surfaces of these steel members is just beautiful. So this again is AESS level 3. You can walk up and touch the steel, which is why we chose level 3. And the final product of this canopy was fascinating. I love it. It's great to walk under. Here's another look at that canopy. You can see on the very far on the left there, we also had steel that was outside of the building in some patios, some site areas. And so we had, again, more of that steel language transcribed throughout the process. So again, that is the presentation. I want to go through some of the high points of the structural system. And thank you again for the time to present this project. And good luck with your judging. And again, thanks for your time. Have a great day.